to ask me anything. Thanks to everybody who has sent me questions on social media. Now, my wife has very kindly agreed to ask these questions, so fire away with the first question.
Peter Keel, given that we can detect the edge of the universe, where are we in relation to the centre?
Well, we can indeed detect the edge of the universe, which is an incredible achievement for the human race. But when we talk about the edge of the universe, we mean the edge of the observable universe. See, the key thing you have to remember is that the universe was born. This is probably the greatest discovery in the history of science. The universe has not existed forever, it was born. It was born in a fireball of the Big Bang 13.82 billion years ago. And what that means is we can only see the stars and galaxies whose light has taken less than 13.82 billion years to get to us. Okay, and those galaxies total about 2 trillion, and they exist in a bubble of space around the Earth, around the Sun. And of course, we appear at the centre of the observable universe. And in fact, anybody else in the universe will think that they're at the centre of the observable universe as well. But our observable universe, I told you it's like a bubble. Imagine it as a soap bubble with a membrane around the surrounding it. We call that the light horizon of the universe. And beyond the edge of that light horizon is more of the universe, in exactly the same way as there is more of the sea beyond the horizon on the ocean. And really, basically, this light just hasn't got here yet. So, for instance, objects whose light would take 14.82 billion years to get here, their light is still travelling to us and won't get here for another billion years. So the question is, how much of the universe is beyond our horizon? Well, according to the standard picture, which is called inflation, it could be an infinite amount beyond the edge of our universe. So if you think of our observable universe as a little bubble containing 2 trillion stars and we are at the centre of that bubble, there could be an infinity of other bubbles beyond. Next question.
Dog days. How do we know time has been flowing at a constant rate? Could it have been at a different rate during inflation?
Well, that's a very interesting question. But the whole idea of the flow of time is fraught with problems. So something flows, for instance, a river flows with respect to a riverbank. So if we think of the flow of time, it would have to flow with respect to something else. There'd have to be a second type of time. But anyway, let's accept the concept for the moment. Einstein's theory of gravity tells us that time flows at different rates in different gravity. So when gravity is strong, it flows more slowly. So that means if we imagine the expansion of the universe in reverse, like a movie in reverse, and the universe compressing down back towards the Big Bang, then gravity gets more and more intense as matter gets more and more concentrated. And this is an alternative explanation for the redshift of that we observe in the light from galaxies. So basically, time flows more slowly in the smaller, more concentrated universe, and that causes light to oscillate more slowly, and light which oscillates more slowly is shifted towards the red end of the spectrum. Next question.
Simon Kent. Why is dark matter modelled to be in halos or diffuse clouds? If it only interacts via gravity, why isn't it coalescing with itself like normal matter and forming structures like stars and galaxies?
Okay, in order for a gas cloud the size of a galaxy or the size of a star to shrink or collapse in on itself, the gravity, its self-gravity crushing that cloud must exceed the force of the gas pushing outwards. Okay, so to collapse, a cloud must shed its internal heat some way. Now, in a normal atomic gas cloud made of atoms, this is done by the molecules emitting far infrared light. So they actually emit light or heat which escapes the cloud. So the cloud's interior is robbed of heat and gravity is able to crush the material to make a star or a galaxy. But the key thing you need to know about dark matter is that it does not emit electromagnetic waves. So it doesn't emit any form of light, and that includes heat. So it can't collapse because it cannot shed its internal heat, and gravity can't crush it. And this is why it ends up as these very diffuse, spread out halos surrounding galaxies. Right, next question.
Gavin Boyd. One universe or many universes?
Well, for the last few decades or more, nature has been banging us over the head and telling us that there is more than one universe. And this evidence has come from many different directions. So, for instance, there are the idea that there are other universes with different laws of physics, other universes where the constants, what we call the physical constants, are different. So maybe the strength of gravity or the mass of an electron is different. Other universes with different numbers of dimensions. This is an idea that comes from string theory. No one knows where all these ideas, whether all these ideas are correct, and if so, how they mesh together. So it's looking as if there is more than one universe, a multiverse. But the question is there really a multiverse, or do we just need to change the meaning of the word universe? So if we go back through history, we find that initially, hundreds of years ago, the word universe meant the solar system, which meant the sun and, at the time, 6 known planets. Later, at the beginning of the 20th century, the word universe began to mean the Milky Way. So this is this band of stars that we see across the night sky, and we now know we're part of this island of stars called the Milky Way, which is like a giant flattened pinwheel of stars containing several 100 billion stars. But then in the 1920s, Edwin Hubble, the American astronomer, discovered that our galaxy, the Milky Way, was just one among a large number. We now know there are 2 trillion in the observable universe. So it could be that we are just about to undergo yet another step change in our idea of the universe, and everything we see may be just an infinitesimal part of a greater universe.